And welcome to the webinar CO2 and capture storage for circular economy. And now we are showing in the second session the importance of this kind of project. Why we do this kind of project? So why we need to do circular economy and why we need to do capture storage? They are the basic question. And after our capture storage mathematical model to estimate flux of CO2 capture storage, type of reservoir for capture storage, geological capture CO2 storage, monitoring reservoir during CO2 inaction, estimation of CSS project, estimation of cost, and also the capture storage and circular economy. So basically the problem, the question is the first aspect that we need to underline is the origin of the molecular of CO2. We need to analyze the carbon cycle to understand the circle of carbon and how is born the CO2, because generally CO2 is present after the combustion of the fossil fuel. Naturally is present by millions years ago, and it was emitted in atmosphere by volcans or other natural phenomena. CO2 is not a negative element because that in normal concentration of 3-4% it allows to maintain the normal Earth planet temperature. CO2 emissions have greatly increased in the last 2 centuries to response of international accord of climate action. But at the same time, there is a possibility to create a circular economy using CO2 to recreate methane and also mineral. The effects of high CO2 concentration can be affect the balance of the seas of their acidification. So generally, the sequestration of CO2 naturally is just an existing project. Is a natural existing project that is made, for example, by trees, by sea, and by soil. The problem, the trouble, is the increasing of concentration and the part for millions of concentration of CO2 after the second industrial revolution and intense use of fossil fuel. We show the emission of CO2 by year in Europe. This map shows the emission of CO2 in Europe. And for example, we have for example Italy, that we have different condition of emission, that we have some part of Italy that we have a high emission and other part that we low emission. We have also analyzed the CO2 emission by sector. The most contributed became by oil and gas processing. The source of CO2 by dimension points. So red big points represent the big emission of CO2. Also orange and yellow. Thank you to Shell that donate us this scheme of the capture storage, typical capture storage, CO2 capture separated by different technique, physical or chemical, using chemical solvent, and capture CO2 is separated from the solvent and compressed into a liquid form for transport. CO2 is generally pumped through a pipeline, taking the CO2 from the industrial site where it was produced to its storage site, and which may onshore or offshore. First part of realize this a plant is to storage CO2. It is injected in depth underground into space with porosity rock, layers of impermeable rocks called the couple rocks, lie directly above the porous rocks, ensuring that CO2 remains free permanently. After we realized the project, we needed to monitoring and verify the security of project and plants and all of the area interested by project. Monitoring of storage site takes place within storage reservoir, as well as that in action, where sensor can be detected small change in the pressure of CO2 levels. What we need really to underline that in this kind of project, instead of, for example, oil and gas reservoir project, is the pressure that is increasing in time and not decreasing in time. Generally, the pressure in oil and gas project decreasing in time in reservoir. So, next slide we show a typical plant of CO2 that is a plant that with a high complex engineering construction, because we have different parts for capture, for purification, for fuel preparation, mixing, and other else, transporting. So, but today, as a company, we are focused especially in exploration project, but we are also really, the reality is that that this project is very difficult by technical aspects and engineering aspects, because we need to estimate how many ton of CO2 we can capture along the time to have a really clarified budget of project and the effects on ambiental pollution, on the application and circular economy, and so like that. We have different techniques to make sequestration of CO2. The first technique is an ancient technique, is based on physical method, and but today the physical method can be substituted by chemical method based on cataclysmic and chemical reaction. Recently, we have developing by MIT, University of MIT, the last is electrochemical method to separate CO2 by atmosphere. How calculate the CO2 sequestration? Mathematical methods and physical methods allow for this kind of activity that are extremely complex and require a large computation power. The current most used method is to measure the molar sequestration of CO2 in given a volume atmosphere, and using flower meters to estimate how many moles of CO2 can be sequestrated during 24 hours. The next graph show an analyzing the flux of CO2 during sequestration, and generally we use the unit used to represent is the mole meters cube by day, because we calculate not the mass in kilogram but by mole in according to chemical unit. And so we have also a case of study outside, some study analyzing Spain and reported by some geoscientists. Which model we use to determine the flow of CO2 into reservoir and the effects? There is a complex model. Generally, we are supported by artificial and intelligence with neural network, and with different input that regards, for example, the measuration of initial condition of CO2 in atmosphere, but also the how you say the concentration, and for example the concentration after 1 hour of sequestration. So we make a balance, and also we make a model of reservoir and the change of parameters of reservoir when we make injection. So we have a very complex model. Status of art of CSS project in world. This kind of project starts about 10 years ago, 10, 12 years ago. First project and first analysis that are also made by European Commission. And now we have about 15 projects realized in worldwide, and red we are project that will start. So we need also to do a comparison between CO2 emission and storaging, because we need also to do a prevision of the impact of the next project that we are realizing are sufficient or not sufficient to reduce the quantity of CO2 in atmosphere, instead the prevision of the CO2 emission, because we have much more pace of state that are economic increasing and are make expansion like China or other pace, and so the emission of CO2 is we have an expected of low increasing now from 2020 to 2050. We are increasing about this kind of increasing. So the budget of CO2 sequestration is this, can be have this kind of effects, cut all this part. So it's very important for atmosphere pollution, but we can say in next part of webinar we have also an important for a possibility, because one of theme of this webinar is how transform a problem in a possibility. So the first part is more complex because they needs a high engineering, high physical and mathematical aspects. Second part is regarding the reservoir and how storage CO2. What kind of reservoir we are searching? We are searching different type of reservoir. Instead, oil and gas project, here the importance is done by the security in time. One of this kind of project can be a duration about to 20 years for 15 years. So it's very important to find a very high security reservoir to storage CO2. And which kind of reservoir we are searching? Principally, we are searching not fractured reservoir, but we need also a porosity, because if you have porosity, you can storage gas. Second solution can be dissolved gas in another phase that is liquid or gas. So the only possibility is the aquifer, saline aquifer. And third possibility is use, for example, sandstone rocks with medium porosity. We analyzed and fourth possibility is the enhanced old gas or oil reservoir. We have basically the four possibility. All possibility is good for the CO2 storage. The next step is underline which is the best reservoir to reuse CO2 and make circular economy. So this is a base scheme of sequestration and action of CO2 into subsoil with numeric modeling to underline and to visualize the effects of the CO2 in action in subsoil, especially in face of we have just realized project plans. We start to monitoring, and so we realized a mathematical a numerical model that show the effects of plumb on subsoil. To understand really in depth the impact of CO2 reservoir and the possibility to reuse the CO2 for circular economy, you need to understand and to study attentively the graph of PT pressure, of the graph of phase PT pressure and temperature on molecular CO2. There is a range of temperature in which CO2 remains in state of vapor or in state of liquid. After this temperature, around 0 degree Celsius, they pass to phase of gas. So why is so important this graph? Because they correlate pressure, and so they correlate pressure and temperature. And so if you go under in depth, you need to remember that we have an minimum increase of 3 degrees by kilometers. and pressure is determined by the type of rock that is constituted the reservoir. So when we are searching a reservoir, we need to combine the geological characteristics to the thermodynamic characteristics to, for example, if you want to realize a project that is not only for sequestration of CO2, but we want to realize also a circular economy to use CO2 for fuel or for to recreate methane or bioethanol, you need to remember that the pressure can be under this value, under 100 bar, and the temperature can be here. So is the purpose for that generally we prefer saline aquifer because we can be dissolve the CO2 in water with chemical reaction, and after we can extract that and separate it with chemical methods. So it's very important graph that related pressure and temperature of CO2. As just we say, the typical reservoir that are found is aquifer saline traps that allow the dissolution of CO2, carbonate reservoir that allow mineralization. In this case, is particularly important for projects that involve the application in circular economy for create, for example, cementing, graphene, and others. Exhaust oil and gas recovery or stimulation, injection, and also sandstone reservoir. Here we have a map of Europe with the location of potential area storage, particularly saline aquifer and hydrocarbon fields. The major saline aquifers are concentrated in northeast of Europe, Poland, Germany, Denmark, all North Sea, and this part, some part of south of France, east coast, northeast coast of Italy. There is a map of the project that we are realizing in UK, and in particular we have in grey the project onshore and other in offshore North Sea. As in USA, we are studying a possible solution to capture CO2 in scale of orange to red. We have the emission of CO2, and in scale of gray is the potential storage, different area of potential storage. Which is the potential storage in Europe? In Europe, we think we are just studying by the European Commission that the Russian study in European can be stored about 15 gigaton. The major carbonate reservoir are mapping in North Sea and by hydrocarbon fields, both south part of UK, Netherlands, and North Germany. The total storage is estimated in 25 gigaton in these hydrocarbon fields. How is made a aquifer saline traps? Basically, aquifer saline traps is based in this way. We have a deep saline aquifer with caps rock, between two caps rock, and generally is more extended because we can find the depths in aquifer under a part of the sea, but also under a part of the coast. And what's happened when we make injection in aquifer saline trap? The effects is clear as and is studied also with sample. Here we have a sample that we have bring in a project, and so when we make injection, generally the injection make distance between two grains of if you are in sandstone traps, or create a bubble in the water. So here is the bubble, and here is the representative of this solution of CO2, like fluorescence. So we have also studied the effects on sample carbonate rocks. Carbonate reservoirs are combined with oldest oil field that can be represented a good cap rock, but the problem is the porosity. Carbonate rocks are very strength, and porosity can be changed. So we generally create a high overpressure. But we have a good chemical interaction between CO2 and carbonate rocks, because the reaction between CO2 and carbonate rocks can generate, for example, compost of magnesium, of calcium CO2. And basically we can have this kind of reaction. If the carbonate rocks contains a small part of water, of molecular water, we have an acidification. Acidification with the reaction of carbonate rocks can be created, for example, the compositive of ferrium, of magnesium. We have also the analysis make on different samples by wells. First type of reservoir. Reuse an old reservoir that in the past contains oil and gas. So we can make a wells injection. We have a reinjection wells, and we can be also enacted to stimulate the end life of oil and gas reservoir, because it's like a gas that we can mix to other, and can be allows the upper of gas. Where we do this, we will do also on platform. We can use, for example, platform to make a capture storage. We have wells of extraction and wells of injection. Is last. The last type of reservoir is sandstone. Classic. You have good geological, is classic geological capture, geological storage, because sandstone have a good porosity, and so is easy to storage gas, but that not allows to bring other use of CO2. We need also to underline to follow geological criteria, because with past experience of the project, we have underlined that we have also a criteria, geological criteria that allows to do this kind of project. And we have also a minimum to maximum depth of project. Generally, according to the pressure temperature graph of CO2 and dissolution of CO2, maximum depth is 3,000 meters offshore. Based on the properties of solubility and temperature, which are the parameters suggested by literature best range of geological parameters. Some one of these are similar to the parameters that are searching in reservoir oil and gas, but others are different. Clear, we analyze density, we analyze viscosity, and we analyze depth. It's clear that, for example, if you use a saline aquifer to storage CO2, is impossible, is much more convenient use saline aquifer and combine that with a project circular economy, because we have a risk that the saturation of to arrive to a saturation after many years, saturation of dissolution with a very high concentration. Optimum reservoir and water parameters. Depth can be this. Thickness of cap rocks minimum 15 meters. Porosity about measured than 20%. Permeability and salinity are this table contains the optimum reservoir parameters. I explain in the past part the storage of CO2 is also controlled by thermodynamic parameters, pressure and temperature. There is a depth, a critical depth, in which CO2 change phase. CO2 as gas exists between from atmosphere to under 800 meters depth. After that, the pressure make a very compression of molecular and the density of CO2 increasing, and so it passes to supercritical fluid. So we have realized project, we have realized plant, all seems to function, but we need monitoring, because I will say at the first part of webinar, they're very different to find the reservoir for storage CO2 and a reservoir for oil and gas is that because the pressure increase in time. During CSS project, it is very important to monitor the effects, either because there may be micro earthquakes or even swelling phenomena. In this regard, the pressure inside the reservoir, the degree of saturation are also monitored. Also the saturation. We do this kind of monitoring with different technique. remote sensing, seismic, surface seismic, microseismic, cross-well seismic, and recently we have developed this technique that is represented by optical fiber cable sensor. Optical fiber sensor installed in well in action allows to do a continuous and high precision passive passive seismic monitoring. So what is the results of monitoring can be different because we can connect, for example, for optical, we can add to optical fiber sensor a sensor of temperature, a sensor of pressure, and is very important because finally we have different results of monitoring. The first results is to show the evolution of CO2 plump in map. After, for example, 8 years with seismic interpretation, we have the first results of inaction. And inaction having increasing in time, and so after other 7 years, the expansion of plumb in space that is represented in map that is here. So we can add, I will say, a sensor of pressure, a sensor of temperature, and have monitoring parameters of reservoir not only in map but also in kind of thermodynamic condition. For example, to estimate the grade of saturation if you are make a circular economy project. Spoke about the cost of this kind of project. This kind of project are not free, are so expensive, but we need to also make a comparison with the effects. The major budget is involved in the first part, in engineering part, to study, for example, the quantity in the flux of CO2 captured, and also to realize the whole structure of plant. Today, for the existing plant, we have an estimation that carbon CO2 capture storage by ton sequestered is between a range of $15 to $120. So it's not so high because we can combine this kind of plant with different other plant, for example, with solar and storage, wind storage. So this is a cost. An estimation of project is very complex to do, and also an estimation of benefits instead the cost of project. Generally, we can say in action wells, to have any ideas of cost, euros by ton of CO2 storage, is that the major cost is the initial cost, modeling log cost, seismic survey, in-action testing, new exploration wells permitting. We have a NIG incident part, for example, 5.9, structure, in-action wells, and after operating. And so generally this kind of project have a low cost of decommission after about 15, 16 years. But we need also to consider the effects, the good effects on atmosphere pollution and the possibility to establish a local circular economy. Scope of this kind of project are focusing to point. First, respect European Regulament and Accord of COP26. Second, develop a local economy with the method of circular economy. So we have different solutions. For example, the sequestration of CO2 can be allows the production of carbonated feedstocks, can be reused in construction for construction material or others. We are also used in transportation and storage. In this slide, we show some selected reuse application. Fuel, for example, to create syn fuel or microalgal fuel, enhanced oil recovery, conventional or unconventional CO2 AOR and CO2 in residential oil zone, construction materials, cement and aggregates, plastic and chemicals, biochars, and so. Here is a detailed possibility that this kind of project and circular economy offer to use CO2 and not only to make only atmosphere pollution, but also create a local impact. Combining hydrogen with CO2 to produce hydrocarbon fuels, including methanol, synfuels, syngas, could produce a huge market. Enhanced oil recovery. Injection of CO2 into oil wells can increase the production for oil. Normally, operation maximizes oil and CO2 recovers from the wells, but it's possible to create AOR from more CO2. Carbon fiber. Also, you reuse CO2 to create carbon fiber. Create microalgae. Using microalgae to fix CO2 at higher efficiency and then processing the biomass to make products such as fuel and high-value chemicals has been the focus of research efforts for many years. With complex production economies, costs are between today so expensive, but they are thinking that the technologies can be reduced the cost. Enhancing water is a new frontier. Crushing rocks such as basalt and spreading them on the land can result in the accelerated formation of stable carbonate from atmosphere CO2. It is likely that doing these agricultural lands will result in enhanced yields. Moreover, the very early stage nature of this pathway means that we have not made between the next 20 years estimated. Mineralization, cementing and carbonate reservoir. CO2 can be used to cure cement or in these manufacturing aggregates. During source rates, some CO2 for long term and could displace emission intensive conventional cement with accelerating global urbanization. But challenging environmental environment, we estimate a utilization and storage increasing in next 20 years with a cost between $13 to $17 by ton of CO2 storage. The demand and the request of this kind of project trend and the various application depends especially on cost, but we can see the technology are decreasing the cost, and so we expected an expansion of the possibility. This is a research made by McKinsey and Company that show the euros, the dollars the dollars that can be not invested but can be received to ton of CO2 storage. The major sector for is an example for carbon fiber or biochar, or also plastic products, and difficult sector that are in negative fuel and feedstock chemicals. So thank you for attention. It was a very pleasure to speak with us about in this webinar, and for all information, question or curiosity, you can write at info@gexploration.ltd.eu.